Section 7.3, the central limit theorem for sample proportion. From the section 7.2, we talk about the sampling distribution for sample proportion. And for these sessions, we're going to focus on the central limit theorem. After we know what is the central limit theorem, we want to find the probabilities. First, central limit theorem for sample proportion. We use to estimate proportion in a population. Tell us that if some basic condition are met, the sampling distribution of the sample proportion is close to the normal distribution. Remember, we learned about the sampling distribution of the sample proportion in section 7.2. If we could increase the sample size, the histogram will become symmetric. If we take a random sample from a population, and if the sample size is large, and the population size is much larger. Remember on the section 7.2, we talk about that if we increase the sample size, then the histogram will become symmetric. And we need the population size is 10 times of the sample size. Then the sampling distribution of the sample proportion is approximately normal. So the graph is going to become symmetric with a mean of population proportion, and the standard deviation become the standard error. So this is how we find the standard deviation for the sample proportion. If you don't know the value of the population proportion, you can substitute the value of the sample proportion. Remember, we talked about the estimator sample proportion is unbiased. So we could use the sample proportion to estimate the population proportion. So if you don't know about this value, you could use the sample proportion. Conditions for the central limit theorem for sample proportion. First, sampling is random and independent. Second, large sample. The sample size n is large enough that the sample expect at least 10 success and 10 failures. So we do have the formula in here. One of the requirements, you have to plug in the sample size times the sample proportion. It has to be greater than 10. And the sample size times the failures. Remember, the p hat, q hat is a complement, right? So sample size times the failure has to be greater than 10. Big population. If sampling is done without replacement, the population must be at least 10 times larger than the sample size. Make sure you guys remember these three requirements for the central limit theorem for the sample proportion. This figure shows the sampling distribution for p hat for 10,000 samples of size 10 drawn from a population with p equal to 0.25. So the population is going to be 10,000, but our sample is only equal to 10, right? So you can see this is not the normal distribution because it doesn't fulfill the requirement for the second one, right? If I use the n times the sample proportion or population proportion, 10 times this guy is only 2.5. That is less than 10, right? So it doesn't fulfill the second requirement here. And that's why this is not the normal distribution. Okay, this one. This figure shows the sampling distribution for the p hat for 10,000 samples of size 100. So sample size times the p, that would be greater than 10, right? That would be 25. Or sample size times 1 minus p, which is going to be 75. So both of them meet the condition 2 here. Okay? And then number 3, the big population. The population must be at least 10 times larger than the sample size. So this is good, right? 100 times 10, that will be less than the population in here. And since it fulfilled the condition of the central limit theorem, so the shape of the distribution is approximately normal. Okay, let's find the standard error. We know the mean will be equal to 0.25, right? We need to find the standard deviation, which is going to be your standard error. So we're going to plug it in 0.25 times 1 minus 0.25 divided by n. N will be your sample size, 100. So you're going to get 0.0433. This is going to be the standard deviation. Okay, let's do the example 1. 59% of vegetarians are women. Suppose a random sample of 500 vegetarians is taken. What is the approximate probability that the proportion of females in our sample will be more than 63%? So first, we want to check the condition. This is the random sample, right? Random and independent. Number 2, do we have the large sample size? We're going to calculate the n times the p hat. Okay, n will be 500 vegetarians. And what is the p hat in here? That will be 59%, right? So use a calculator, you're going to get 295, which is going to be greater than 10. This is good. And then second one, we're going to multiply the n times the failures. Plug in the numbers. You're going to get 205, which is going to be greater than or equal to 10. So it fulfills the condition 2. Condition 3. We can assume that there are at least 10 times 5,000 vegetarians in the population. So it fulfills the three requirements. What is the approximate probability that the proportion of females in our sample will be more than 63%? So we know we could consider the central limit theorem. So the mean will be equal to the sample proportion, 0.59. Now we want to find the standard deviation. Plug it in and see what you guys get. You should get 0.022. Okay, right? We have the mean, we have the standard deviation. Now we want to find the probability. Okay, remember in the chapter 6, when we want to find the probability in the normal distribution, what we are looking for? We are looking for the area, right? So we're gonna have the normal distribution, and then this is the way how your book will present the normal distribution. This is the mean. This is gonna be the standard deviation. Okay, so the mean in the middle here, 0.59. And we want to find the probability, means find the area of getting a value larger than 0.63. So 0.63 somewhere like here. Larger than. So we are looking for the area of this part here. Remember how to do it? You're going to use the normal CDF or you're going to use the inverse now. So first, we're going to write that out. X greater than, because we are looking for the area of this part. X greater than 0.63. We'll be using the normal CDF, lower value, upper value, and then the mean, and then the standard deviation. If you guys don't remember on this part, please review the chapter 6. Use your calculator. You're gonna get 0.0345. So the probability that the proportion of females in the sample will be more than 63% is gonna be 0.0345. Okay, like this kind of the example, I want you guys First, check out the condition to see if it fulfilled the requirement for the central limit theorem. Okay, once it fits for the three conditions, you could find out the mean and the standard deviation. The mean will be the population proportion or the sample proportion. Then we're gonna find the standard deviation. After you have the mean, you have the standard deviation. It fulfills the condition for central limit theorem. Then you will have a normal distribution here. Here we're gonna find out the area. Okay? Okay, example 2. Try to do it by yourself. I want you guys, number 1, check out the condition. Number 2, find out the standard error, means the standard deviation for this sample proportion. Okay, number 1, we have a random sample, right? Random and independent. Number 2, we're gonna check the sample size, right? So n, the sample size will be 80 times the p hat, which is gonna be 0.5. So that's greater than 10. And then sample size times the failure. Same thing, right? Which is gonna be greater than 10. So this is good. And then we want to check the population. So our sample is 80. We will believe that at least like 800 voters in the district. Okay, so the population size is at least 10 times larger than the sample size. So the condition for the central limit theorem are met. So this is good. Now, use the formula to find out the standard error or standard deviation. Okay, check your work. You should get 0.0559. Okay, right? Check the requirement for central limit theorem. Second part, find out the standard error. Number 3, if so, what is the approximate probability that the sample proportion will fall within 2 standard error of the population value, p equal to 0.50? Okay, remember 2 standard error means like the 2 standard deviation. And since they meet the condition of central limit theorem, we know that the distribution will become normal distribution. And we have the mean, we have the standard deviation. Since they are talking about fall within 2 standard error, so we could find it out, the mean minus 2 standard deviation and the mean plus 2 standard deviation. Okay, plug it in. You should get 0.3882 and 0.6118 here. So what is the probability that the sample proportion will fall within 2 standard error? Okay, we're gonna use normal CDF, right? Lower value, upper value. Okay, this is a mean minus 2 standard deviation. This is the mean plus 2 standard deviation. And then the mean, and then the standard deviation. Okay, you should get 0.9545 here. This is the first way to work on number 3, or remember the empirical rule, right? The 68%, 95%, and 99.7%. Within 2 standard deviation, actually that will be 95%. You could just write it down by the empirical rule. you're gonna know that the sample proportion will fall within 2 standard deviation is 95%. Key idea: if the condition for the CLT are met, probability that a sample proportion will fall within 2 standard error of the population value is 95%. Okay, you could think about it. That's like the empirical rule, right? Within 2 standard deviation, there will be 95%. Example 3. I want you guys try to do it by yourself. Check the condition for the CLT, find the standard deviation, and look at the number 3, what they are looking for. Okay, number 1, random independent sample. Number 2, check the sample size. Okay, we have, what is the n equal to? We do have a 200 sample. And then the p-hat will be 36.5% of all Americans own a dog. Okay, so this is gonna be the sample proportion. You should get 73. And then n times the failures, which is gonna be 127, which is gonna be greater than 10 as well. Number 3 is the population is at least 10 times larger than the sample. This is talking about all Americans. So for sure, the population is at least 10 times larger than the sample. Okay, then find the standard deviation. Plug it in. You should got 0.034. Okay, then what they are looking for. Would it be surprising to find that 45% of the sample own a dog? Why or why not? Okay, 45%. So first, 45%, and what is our mean? Our mean is 36.5, right? So first, we try to find the maximum user. We know the mean, you know the standard deviation. You should get 0.433, right? And this is means like 43.3%. This is the maximum user. And then they are asking for the 45% of the sample, right? So you know 45% is more than 2 standard error from the mean. So it would be surprising.